All right, so today we are diving into a pretty wild proposal for how to build a true artificial intelligence. The whole argument is that for all their incredible power, today's AIs are missing one absolutely fundamental ingredient. And that ingredient is something the source calls synthetic load. Yeah, it's an idea that might just change, well, everything. I mean, we all see what current AI can do, right? It's just spectacular at chewing through tokens and predicting what word comes next. But there's this whole other side to it, a whole class of things it just can't do. It can't absorb any real structural pressure. It can't deform, it can't reorganize itself when things get tough. It's kind of like it's just shuffling symbols around. It never actually feels any of the strain. And that right there, that leads to the huge question that's at the heart of this whole idea. What if that ability, to handle strain, to bend, to maybe even break and then rebuild itself, what if that isn't just some neat little feature? What if that is the absolute key to building a machine that can genuinely, truly think? Okay, so to really get our heads around the solution they're proposing, we've got to understand the core idea first. We're talking about cognitive load. But, and this is super important, not as some kind of metaphor. We're talking about it as a real, almost physical force that literally shapes how thought happens. So what exactly is this load? Well, the source puts it really simply. It's the structural demand placed on a cognitive architecture. The best way to think about it is like putting weight on a bridge. See, it's not just another piece of data, it's a real force that the bridge, the structure, has to physically deal with. So what does this force actually do to the system? Well, it forces it to change its shape. It makes it bend or stretch or integrate different parts of itself. It'll try to stabilize, or if the pressure gets to be too much, it might even collapse. And yeah, all these words sound very physical and dynamic for a very good reason. Okay, and this is where the really critical distinction comes in. You see, an AI today would just treat load as, well, another number to process, right? Another token. But this idea says, no, no, no. Load has to be a real dynamic force that actually propagates across the system's entire structure. Its network, its topology. It's got to set off a chain reaction, almost like a shockwave. All right, so if load is this kind of physical force, then the next logical question is, how on earth do you build an AI that can handle it? And that brings us right to the heart of the whole proposal, designing a mind that can actually bend under pressure instead of just, crashing. So the proposal lays out this whole dynamic system for how this force would move around. It's not as simple as just going in a straight line. The load can move directly, sure, but it can also spread out sideways, bleeding into other parts of the structure. And this is the cool part. It's not a constant thing. It can get amplified in certain spots, get dampened by other more stable parts, or even trigger a huge cascade if it breaks through some kind of threshold. It's a living system. Okay, so that's the million-dollar question, right? If you have this force rippling through the architecture, what's the end result? What actually happens to the mind itself? And the answer is surprisingly simple, but also really profound. It deforms. The actual structure of the system changes its shape. And get this, according to this model, that deformation is the act of thinking. The source breaks this down into 3 different kinds of change. First up, you've got what's called elastic deformation. The best analogy is bending a plastic ruler. The system is under pressure, so it bends and changes to deal with it. But as soon as that pressure is gone, snap. It goes right back to its original shape. You can think of this as temporary, flexible thought. Then there's plastic deformation. Now this is more like bending a paperclip. The structure changes under pressure, but this time it doesn't go all the way back to how it was. A real lasting change has happened. This is basically the model's version of learning, or adaptation, maybe even trauma. And finally, we get to the most dramatic one, structural failure. Now, I know that sounds like a bad thing, but in this model, it's actually a feature, not a bug. This is when the load is just so huge that the old structure simply can't handle it anymore, and it completely collapses, but then reorganizes into a brand new stable state. Think of it like a huge aha moment, a paradigm shift, a total cognitive breakthrough. So what you end up with is a totally different kind of artificial mind. So let's actually put them side by side. Let's compare this idea of a structural mind with the stochastic minds we have today. The ones that are all about predicting probabilities. And wow, this chart just lays out the difference perfectly. The core function of today's AI, predicting sequences. A structural AI, it changes its own state. When an LLM is under pressure, what does it do? It just processes more data. But a structural AI would literally deform. And check out the failure mode. This is huge. Our models today become chaotic, unpredictable, they hallucinate. This proposed model would fail in predictable ways. That means it's structurally explainable, not just some magic black box.
Look, this isn't just some academic thought experiment. The implications for the future of AI here are absolutely massive, especially when you start thinking about safety and, building systems that we can actually trust. This might just be a much, much better path forward.
It's kind of ironic when you think about it. By building an AI that has actual structural limits, that has predictable points where it will bend or even break, you actually make it way, way safer. It suddenly becomes interpretable, stable, transparent. Because its thought process is tied to a structure we can examine, we can actually start to understand why it does what it does. It's not just swimming in a chaotic ocean of probabilities anymore. And really, this whole thing boils down to one incredibly powerful line from the source material. It says, "Load gives synthetic minds something stochastic systems lack, a reason to think."
Just let that sink in for a second. We're not talking about a reason to predict the next word. We're talking about a reason to fundamentally change its own structure. It's about creating an internal structural need for the system to change itself just to deal with the pressure it's feeling. That's a completely different kind of motivation.
And so that leaves us with this final big question to chew on. If we run with this idea that thinking is really just a structure changing its shape under pressure, then what kind of future are we looking at? What happens when our machines, for the first time ever, can finally bend?